Several people are having difficulty with rational exponents and factoring, so I just wanted to show you a quick little example. For instance, this is a nice little short little binomial, and you start with the numbers like normal, greatest common factor of 24 and 16, and you'll find that that would be 8. And then what you do is you look at the two variables, which in this case are x, and you pick the smaller of the exponents. So the smaller of the exponents is this negative 2/3. So we're going to factor out x to the negative 2/3. And when you do this GCF factoring, technically what happens is you're dividing out everything that's left behind. So in here we have 24x to the negative 2/3. I'm just copying down the original problem, but we're going to divide out some stuff. Minus 16x to the positive 4/3. All right. Oops, might as well keep the same color. And then we're going to divide out exactly what we pulled out front. So we're going to divide out 8x to the negative 2/3, both pieces. And what this does is it guarantees us the correct pieces left behind. I mean, think of it. If I distribute this chunk on the outside, it's going to cancel with the two pieces that I just put in the bottom, and you're back to the original problem. So it's going to work perfectly. So on the outside is still this 8x raised to the negative 2/3 power. And then left behind, 24 divided by 8 is 3. X to the negative 2/3 divided by x to the negative 2/3 is just 1. Negative 16 divided by positive 8 is going to be negative 2. And then we have this x to the 4/3 divided by x to the negative 2/3. Well, the operation that you use on exponents is subtraction. So you can go off to the side and go 4/3 minus a negative 2/3. So that would become 4/3 plus 2/3, which is 6/3, better known as 2. So that becomes x squared. And there's your factored form of the original well, it's not a polynomial, but the original expression. All right, they might get a little messier. For instance, we could have something like this, but it works about exactly the same way. The chunk that is the same as this 3x plus 4, one's raised to the negative 1/3, the other one is raised to the negative 4/3. So we're going to take out the smaller of the two, and this one is smaller. You have to think of it on a number line. It is further to the left than negative 1/3 would be. Nothing else is going to come out except this 3x plus 4. So when we kick out the 3x plus 4 to the negative 4/3, the smaller of the two exponents, we're going to have a mess left behind. So I'm going to put brackets. Now when I divide it out here, I'm not going to do it like last time where I showed the work. I'm just going to do it mentally. 3x plus 4 to the negative 1/3 divided by 3x plus 4 to the negative 4/3. We can go off to the side and we'll have negative 1/3 minus a negative 4/3. That's better known as negative 1/3 plus 4/3. And then that turns into 3/3, which is better known as 1. So when we do this division, we're just going to get a power of 1 out of it. So it's going to have that factor of 2 sitting in front, and then 3x plus 4 raised to the first power, minus, and then we have this 2x minus 1 factor, which is going absolutely nowhere. And then we take our 3x plus 4 raised to the negative 4/3 and divide it by the same thing, so that's just a big fat 1, and you get something that looks like this. And it simplifies, you get 3x plus 4 raised to the negative 4/3. Distribute the 2, we're going to get 6x. Over here we're going to get a minus 2x, and 6x minus 2x is 4x. I'm just combining like terms and distributing at the same time. 2 times 4 is 8. A negative times a negative is a positive. 8 plus 1 is 9. So we're going to get plus 9. And there's our answer. Nice little compact, simplistic answer. These type of problems right here, this is very prevalent in calculus. After doing an operation in calculus, you get this ugly expression, and it simplifies rather nicely into something a little bit nicer. Not horribly nicer, but a little bit nicer. Well, I hope that helps.